Mikio Kaku's perspective on recent cosmic revelations is nothing short of captivating. In light of the groundbreaking images unveiled by the James Webb telescope, Kaku suggests we're on the brink of rewriting our cosmic origins textbooks. These images, long awaited and finally public, showcase cosmic phenomena that defy conventional scientific understanding. The telescope's findings not only challenge established theories on the universe's birth, but also stir up our understanding of exoplanets, pushing the boundaries of physics into uncharted territories. Named after NASA pioneer James Webb, this telescope has become a beacon of discovery, revealing unprecedented clarity in its images. Scientists, initially unsettled by the implications, are now grappling with a paradigm shift. Kaku, renowned for his visionary insights, embraces these developments optimistically. He argues that our current theories are incomplete, citing the disconnect between quantum realms and macroscopic matter as evidence. Now, even exoplanets are flouting the laws of physics, presenting anomalies that defy conventional classification. The telescope's advanced spectrometers have uncovered a menagerie of cosmic oddities, from ancient galaxies to mind-bending exoplanets like Kelt 9b. This ultra-hot Neptune, orbiting dangerously close to its star, defies all norms by its sheer existence. Its scorching temperatures disintegrate water molecules in its atmosphere, a phenomenon so extreme that scientists struggle to explain it within existing frameworks. Webb's discoveries, laden with exceptions and extremes, challenge our very notion of what's possible in the cosmos. In essence, the James Webb telescope isn't just revising scientific dogma, it's pioneering a new era of cosmic exploration, where every image unveils a universe more complex and mysterious than previously imagined. Let's take another look at a world that terrifies scientists. WASP-76b is a giant exoplanet with iron raining from the sky on its night side. The planet orbits its star in a bound orbit and thus has an extremely hot and cold side. The metals that are melted and vaporized on the hot day side solidify into iron in a global cycle on the far side of the planet and then fall to the ground like rain. Once again, scientists are dealing with extreme conditions that impressively demonstrate the physical processes on exoplanets and create more questions than answers. Particularly fascinating and puzzling is the discovery of planets orbiting their stars in the opposite direction to other planets in the same system. Such a discovery forces astronomers to rethink theories about the dynamics of planetary systems and the forces that determine their orbits. WASP-17b is an example of such a crazy world. This planet was found as part of the Wide-Angle Search for Planets, WASP for short. This exoplanet is a huge gas giant that looks a bit like our Jupiter, but orbits its star in a retrograde orbit, which means that its orbital direction is opposite to the rotation direction of its star. Until now, this was considered scientifically impossible, according to current theories of planet formation. All planets in a system should orbit their star in the same direction as they evolved from the original protoplanetary disk. One theory that explains such orbits is that gravitational perturbations from nearby passing stars or other massive planets in the system can dramatically alter the orbit of a planet after its formation. Another possibility is that a gravitational dance between several large planets can cause one or more of them to be pushed into a retrograde orbit. When we look for crazy planets, we don't have to look beyond the boundaries of our solar system. In the Kuiper Belt, we find the dwarf planet 2007 or 10, which scans have shown to be unusually dark and red. Scans with Webb spectrometers show that this planet is probably rich in complex organic compounds that scientists call tholins. Despite its considerable size and peculiarity, 2007 or 10 has so far remained without an official name because the planet's exact orbit has not yet been determined. The probable composition, the organic substances that are ultimately the building blocks of life, and the unusual color do not fit the picture of the other dwarf planets in the Kuiper Belt. Where does this planet come from? How did it form? And why is it so hard to see? Due to its great distance, It's extremely difficult to observe 2007 or 10 accurately and over a long period of time. Even with our best telescopes, 2007 or 10 is possibly the third largest dwarf planet after Pluto and Eris, and researchers see it as an important key object for understanding the dynamic processes in the Kuiper belt and the evolution of the entire solar system. Planets without a star. Is that possible? Would you have believed that there are planets without a star? Planets actually form in the dust and gas disks left over from the birth of stars. Then they remain gravitationally bound to their star. At least that's what you would think. However, vagabond planets show that this does not always have to be the case. Such planets are cosmic loners without a star that drift freely through space. But where do they come from, and how can they survive in the hostile cold of space? Vagabonding planets can form in different ways. One common way of formation is ejection from their original star system. This can happen through dynamic interactions with other planets or close stellar flybys, where the gravitational forces are strong enough to pull the planets out of their orbit. Another possibility is that they were formed as isolated objects in a star-forming region, similar to stars, but without sufficient mass to initiate nuclear fusion processes. This could also explain the existence of jumbos, for example. Jumbos are Jupiter mass-like objects. As the name suggests, they are similar in size and mass to Jupiter, which is itself considered to be an obstructed star. Jupiter, the largest planet in the solar system, would not have lacked so much mass that it could have started nuclear fusion processes itself. However, the necessary little bit was missing, and so it only became a planet. James Webb shocked the scientific community once again when the telescope discovered 80 such vagabond Jupiter planets in the Orion Nebula. The really bizarre thing about this discovery is the almost unbelievable fact that these 80 Jupiter-like planets have formed 40 binary systems. This means no less than that there are 40 vagabond pairs of planets orbiting each other in a relatively confined space within the Orion Nebula. This is bizarre and actually scientifically impossible. The mere existence of the many Jupiter-like planets may of course be due to the fact that the Orion Nebula is one of the most intense star-forming regions we know of. However, more detailed investigations then showed that the planets are not really planets at all, but are somewhere between planets and brown dwarfs in terms of mass. Of course, this suggests that they are precluded stars, because brown dwarfs are among the smallest stars we know of. But what processes in the Orion Nebula are responsible for precluded stars, which somehow act like planets, dancing freely through the cosmos in binary systems? The mechanisms behind this are once again an extreme challenge for our scientists. They are probably a class of objects in their own right, and this finding once again pushes the boundaries of our astrophysics. It is possible that such massive free-flying objects are much more common in the universe than we thought. They could be quote-unquote normal, but they are unusual for us because we were previously unaware of the phenomenon. We have not been able to detect exoplanets in the depths of space for very long. Studying them more closely has long been a challenge, and the James Webb Space Telescope represents a milestone in this respect. We are now naturally thrilled by such discoveries, but scientists are slowly becoming overwhelmed by the new phenomena and impossible discoveries. Nothing is as they thought it would be. Has science come to an end? Did you know that the James Webb Telescope was actually created to fill gaps in our knowledge and confirm the theories we already had? Instead of closing gaps, the findings are tearing new holes in the constructs we call truths. Some are saying these days that the crisis Webb is triggered is the end of our old science. As Mikio Kaku has already said, we will have to rewrite our textbooks. But what do we write in them now? No coherent new answers have yet been found, and researchers are desperately looking for new explanations. We may have to say goodbye to the idea that our astrophysics and cosmology can really unlock the secrets of the universe. Become a subscriber now. The best videos are yet to come.